Okay. Again, please do not leave before I take the roll, and you can check with me, or double check with me. Um, so let me just share the slides with you. Okay, so now you should be able to see the slides for 1.6. So we just finished the 1.5 last time, and so we're going to do 1.6. And so we just have one class this week. We don't have class on Friday. Um, I will meet you again on Monday, on next Monday, and then we don't have any quiz for this week. We'll probably have the next quiz in next week. Okay, so we have about 1 month to go for the whole semester. You probably go back to home Thanksgiving, and then you don't have to return to campus. But I think the final exam is scheduled in early December. All right. So we still got a little time left in the whole semester. We're going to have a few quizzes and probably a couple of tests, and then you do the final exam. So that's the basic agenda for us. Let's just do 1.6 today with a couple sections left in this chapter. And so uh, let's talk about other types of equations. I think we talked about the complex numbers in last section. We also discussed the quadratic equations before that. So let's just discuss other types of equations. And the first type is called the polynomial equations. So you got the polynomial, in the equation, and you want to solve it. Like in this example, we need to solve the equation of 3x to the fourth equal to 48x squared. Okay. So one of the things that keep in mind, really be cautious. You do not want to cancel x squared in this problem. Okay, you should never cancel that in this kind of equations. And what you do is you put all the terms on the left side first. So that becomes 3x to the fourth minus 48x squared. And then you can factor the left hand side. So what you can factor is 3x squared. So you should always factor the greatest common factor. For example, just consider the numbers and the variables separately. I think we talked about this factorization before, so you can factor 3 from 3 and 48, and you can factor x squared from x to the fourth and x squared. So then if you factor 3x squared, you are left with x squared minus 16. All right. And then you can further factor x squared minus 16 by x minus 4 and x plus 4 if you still remember, difference of squares. 16 is just 4 squared. So a squared minus b squared equal to a minus b plus a plus b. That's what you use here. And then you just set each factor equal to 0 and solve for them. So 3x equal to 0, you get x equal to 0. X minus 4 equal to 0, you get x equal to 4. And x plus 4 equal to 0, you get x equal to negative 4. So there are three uh, solutions to this equation. Any questions? If no question, then we just go to the next page or next slide. Okay, so let's do some more examples. This time we got the x cubed minus 5x plus 2x plus 10 equal to 0. So you can see all of these equations, including the one we just discussed, have the highest power greater than 2. So they are not quadratic equations. Okay, so that means you need to factor the polynomial first. So So for this problem, we can factor the left-hand side. We don't have to do anything to move around the terms because all the terms are on the left and the right hand is 0. So what do you need to just factor the left-hand side? And for this particular problem, we can factor the left side by grouping. So for example, we can group the first two terms and the other two terms, and then factor each group. So from the first group of x cubed minus 5x squared, we can factor x squared, and we get x minus 5. And for the equivalent to 2x plus 10, we can factor negative 2, okay? To get x minus 5, remember you change the sign where you factor negative sign, all right? So then you get a common factor of x minus 5 for the two groups that you can factor out. And if you do that, what is left is just x squared minus 2 equal to 0, okay? So we got two factors, then you just set each factor equal to 0 and solve each of them separately. So x minus 5 equal to 0, you get the x equal to 5, and x squared minus equal to 0, you get the x squared equal to 2. So then you get two solutions. If you take the root, you get the plus square root, the negative square root 2, and the minus square root 2. So in total, we got three solutions: 5 square root 2 and negative square root 2. Good. Any questions? If there's no question, let's go to the next problem. So this is another problem, polynomial equation we can factor. So the equation is 6x cubed minus 27x squared minus 54x. So again, try to factor some common factors from those three terms. And what you factor is 3 from the numbers 6, 27, and 54. And we can also factor x from x cubed, x squared, and x. So those are the greatest common factors. So then you can factor 3x. And so you're left with 2x squared from 6x cubed, and 9x from 27x squared, and 18 from 54x with all the signs. Now you need to factor 2x squared minus 9 minus 18. And this is a trinomial. We discussed how to factor that in a method called factoring by grouping. Remember that. Okay, 3 steps. You multiply the first number and the third number. So 2 times negative 18. So that's negative 36. And then you, in step 2, you find 2 numbers so that the product is negative 36. The sum is negative 9. So what are these 2 numbers? Those 2 numbers, I think, are negative 12 and 3. Okay, negative 12 times 3 is negative 36. Negative 12 plus 3 is negative 9. So then you can break negative 9x by negative 12x plus 3x, and then factor by grouping. So if you do that, what you get is 2x plus 3 times x minus 6. So I didn't put all the details in here, but you can double check with the notes for and how we do that. And then you put each factor equal to 0. So you get 3x equal to 0, 2x plus 3 equal to 0, and x minus 6 equal to 0. So then you get x equal to 0. And for 2x plus 3, you're going to move 3 to the right. You get negative 3. 2x equal to negative 3 divided by 2 on both sides. So you get x equal to negative halves. And x minus equal to 0, you just get equal to 6. So we got 3 solutions. All right. Any questions about this? Okay, let's do another one. So this one is a little different. We got the, that has the exponent is 4. So we get the x to the fourth minus 3 is x squared plus 2 equal to 0. And again, we need factor it, but before that, we can rewrite the equation using some new variable, okay, for us to see it more clearly. So if you rewrite x to the fourth as x squared to the square, then you can rewrite the equation as x squared to the square minus 3x squared plus 2. Then you can treat x squared as one variable, u. And that's why the reason we need to rewrite x to the fourth minus x squared to the square. So then x squared is just like a one thing by itself. We use u to denote it in here. So then the equation can be rewritten as u squared minus 3u plus 2 equal to 0. And that's a quadratic equation. And you can easily solve it by factor. So if you factor that, you get u minus 2 times u minus 1. Okay, and then now you can plug back in x squared for u in the equation in the factor form as x squared minus 1 times x squared minus 2 equal to 0, right? And then you just set each factor equal to, so you get x minus square minus 1 equal to 0, and x squared minus 2 equal to 0, and then solve it easily for each one by moving the constant on the right side and take the root. So then we get x squared equal to 1 and x squared equal to 2. And then take the root. For each of those, you get x equal to plus minus 1 and x plus equal, minus square root 2. Remember, you always get two solutions, plus and minus, when you take square root. And so for this equation, we get four solutions. Good. Any questions? Okay, so now we just talked about a few examples of polynomial equations. The next type of equation is called radical equation. You got some radicals and the variables is inside the radical. Okay, for example, for this uh, equation, we got negative square root of 49x plus 2 equal to x. So one of the things to do to solve radical equation is always to get rid of the radicals by taking the powers. Okay, so we can move 2 to the right to get the negative square root of 40 minus 9x equal to x minus 2. And then we can take the square, okay, to get rid of the root. Remember, that's how you get rid of the root. Okay. You cannot just take the root from the original problem. Okay, you have to move 2 to the right so that you can get rid of the root completely. So if you take the square for the left hand side, although you can have a negative sign inside, when you square it, it becomes positive. And then you square root the square root the square root of 40 minus 9x. You just get 40 minus 9x. Okay. And then x minus 2 squared on the right will become x squared minus 4x plus 4 if you FOIL it, or you can use the formula we talked about before, perfect squares. So then you can, combine like terms. You can move all the terms to one side and then combine them. So, for example, if we move 40 minus 9x to the right, then you have to change the sign. So that becomes negative 40 plus 9x. And then you can combine negative 4x with positive 9x to get the positive 5x. And for negative 40, you get negative 36. And the whole thing will be equal to 0. All right? And then just factor it. So you get x minus 4 times x plus 9. I don't know why I put the x squared plus 9 here. Sorry about it. It should be x plus 9. So then put each part equal to 0. So we get x minus 4 equal to 0 0, so you get the x equal to 4, and x plus 9 equal to 0, so you get the x equal to -9. All right, so we get roots in here, but then remember we start from a radical equation, so we need to double check the answers. You know, some of the answers may not be the right answer. Okay, when you square the equation as we did in here, we actually changed the equation. Okay, so let's just plug in each answer. Okay, so plug in 4 for x in the original equation, so we get negative square root of 40 minus 9 times 4 plus 2 equal to 4. So inside we got inside radical we get 40 minus 36. 9 times 4 is 36. So that's just the 4. 40 minus 36, and then you take the root of 4, you get 2. So the equation becomes negative 2 plus 2 equal to 4. So 2 plus 2 is just 0 on the left, and then we get 4 on the right. So obviously that's not right. So that means x equal to 4 is not a solution. Okay. And the reason is, as I said, when we square, on the both sides of the equation, as we solve the equation, we actually changed the equation itself. We brought out extra solutions to the original equation. All right. So x equal to 4 is not a solution to the original equation. Then we check the other solution, -9. Plug in negative 9 in the original problem, so we get negative square root 40 minus 9 times -9 plus 2 equal to -9. 9 times -9 is -81, but you get another negative sign in the front, so it becomes plus 81. So 40 plus 81 is 121. If you take the square root of 21, you get the 11. So the equation becomes -11 plus 2 equal to -9. That is right. So x equal to -9 is a solution. It checks. So we're going to only get one solution, -9 for the equation. All right. So that's one of the things you should be really cautious when you solve radical equations. You need to double check the answer at the end. Any questions for this example? No question. Then let's just go to the next example. So again, we want to solve another radical equation here. So this time we got x minus 4 to the 2/3 power equal to 25. So it doesn't look like a radical equation, but if you rewrite in the radicals, that's x minus 4 squared to the cube root. So that's indeed is a radical equation. But you don't have to rewrite into radical form to solve the equation. Rather, you just use the exponent in here and solve it. So what we do is we just cube both sides of the equation, okay, and that will not change anything about the problem, okay. If you square equation on both sides, you're going to change the equation, but if you cube it, you will not change the equation, okay. You know the difference. Okay, so if you cube the left-hand side, then you just multiply 2/3 with 3 for the exponents, so you get 2. So on the left, you get x minus 4 squared. And on the right, there's just 25 to the cube. We can also rewrite 25 as 5 squared. You can simplify this a little bit. You don't have to cube 25, you know. So then 5 squared to the cube, we just multiply 2 and 3, the exponents, you get 6. So that's 5 to the 6, and then you can rewrite 5 to the 6 as 5 to the 5 cube 2 squared, okay. And the whole thing we're doing here is just, you know, to take the square root. So you want to write in the perfect square, so it's easy to take the square root. So if you take the square root now on both sides of the equation, you get x minus 4 on the left and plus minus 5 cubed on the right. Remember, you can just treat 5 cubed as one thing, okay? And this will not change the equation, okay? So everything is good. We will not bring new or extra solution to the equation in all the steps. So I'm sorry. So then you get two solutions, x equal to 4. If you move 4 to and the two solutions will be 4 plus or minus plus 5 cubed and 4 minus 5 cubed. Now 5 cubed is easy to compute. It's just 125. And 5 times 5 is 25. 25 times 5 is 125. So 4 plus 125 is 129. That's one solution, and the other solution is just 4 minus 5 cubed with 4 minus 125, so you get negative 121. So again, we got two solutions to this equation, and they're both solutions for the original equations. If you check it, double check it. Okay, 129 and negative 121. So that's this example equations. So you can see solving this kind of equations usually involve more steps, and you need to be very cautious, and you have to use properties of radicals in many cases. And sometimes, it could be a little tricky. And you can solve the equations in different ways, but you want to do it in an easy way. Okay, let's do one more example about rational equations and absolute equations. Okay. So this is another type of equation, rational equation. So that means you get the rational functions in the equation. So it's not just the fractions, but also the variable is in the denominator. So like in this example, we try to solve the equation of 4 over x plus 2 over x plus 3 equal to negative 3. So, one of the easiest way to solve this kind of equations is to find the least common denominator to start. So two denominators, x and x plus 3. So the least common denominator is just x times x plus 3. But then you don't have you don't. There's no common factor between x and x plus 3. So in this case, you just multiply them to get the least common denominator. And then the next thing is just multiply the least common denominator x times x plus 3 on both sides of the equation. So on the left, you just distribute x times x plus 3 to both 4 over x and 2 over x plus 3. On the right side, you just get negative times x plus 3. All right. So just do the term by term on the left. In the first term, you can cancel x. So you're just left with x plus 3 times 4. And the second term, you can cancel x plus 3, and you're just left with x times 2. Now, if you distribute the 4, in the first term on the left, you get 4x plus 12, and you get 2x plus, and then to add. And on the right hand side, you can multiply, x times x plus 3 times negative 3 to get negative 3x minus 9, negative 3x squared minus 9. X times x plus 3, it's just get x squared plus 3x, and then you multiply negative 3, you get negative 3x squared minus 9x. You just distribute. And so then you can move negative 3x squared or 4x plus 12 plus 2x to the right side. Just move everything to the right side and combine like terms. So 4x becomes negative 4x, and then you get Great. What's going on? Is there anything? Okay, that's good. So 4x and 2x, you got 6x on the left, but when you move to the right side, it becomes negative 6x. And then you can combine negative 9x with negative 60x. Negative 6x, you get negative 15x. And then 12, move to the right, becomes negative 12. So you get the negative 3x, x squared minus 15x minus 12 equals 0. Now you can divide by negative 3 on both sides of the equation. And to get x squared plus 5x plus 4. Okay, you have to divide negative 3 by each term. So it becomes positive, right? And then you factor the left side easy by x plus 1 and x plus 4. So, and then you set each factor equal to 0, x plus 1 equals 0, you get x equal to negative 1. X plus 4 equal to 0, you get x equal to negative 4. But again, you need to double check the answer, because when you multiply the least common denominator from the original equation, you can probably introduce extra solutions to the original equation. All right, so we need to double check again for rational equation, just like radical equations. So these are two extra things you have to do for those two types of equations. So let's just check one by one. So let's just check negative 1 for x on the original equation. So plug in negative 1 for x in the original equation, we get a 4 over negative 1 plus 2 over negative 1 plus 3. 4 over negative 1, you get just negative 4. Negative 1 plus 3 is positive 2. 2 over 2 is just 1. So we got negative 4 plus 1 equal to negative 3. And that's correct. So that means x equal to negative 1 is indeed a solution. Now, how about negative 4? Plug in negative 4 for x in the original equation. We get a 4 over negative 4 plus 2 over negative 4 plus 3 equal to negative 3. 4 over negative 4 is just negative 1. Negative 4 plus 3 is just negative 1. 2 over negative 1 is negative 2. So we get negative 1 plus negative 2 equal to negative 3. And that's all right. So in this case, x equal to negative 4 is also a solution to the equation, to the original equation. Both check. So we did not introduce any extra solutions in the original equation when we solve it. Any questions for this example? So we have one more page, okay, for this section. So let's just do absolute value equations. Okay, so that's a little different. Okay, so you got the variable inside the absolute sign, like in this example. You solve the equation of the absolute value of x squared minus 3x equal to negative 4x plus 6. Again, I think we might have done that before. You can always break up this equation into two, okay, plus and minus. So you're going to get x squared minus 3x equal to negative 4x plus 6. But also, you can have another case of x squared minus 3x equal to negative 4x plus 6. Because when you take the absolute value of x squared minus 3x, whether it's positive or negative 4x plus 6, you get the same thing, right? Okay, so that introduces two equations for us. So x squared minus 3x equal to negative 4x plus 6. If you move all the terms to the right, it becomes positive 4x minus 6. So combine negative 3x with positive 4x, you get the positive x and the minus 6. So you get x squared plus x 6 equal to 0 from the first case. And then the second equation is just the x squared minus 3x equal to 4x minus 6 if you distribute the negative sign on the right. Okay. So then you can move all the terms on the right to the left for the second equation. So 4x becomes a negative 4x, negative 3x combined with negative 4x, you get a negative 7x. And negative 6, so move to the left, become positive 6. So x squared minus 7x plus 6. So we just need to solve those two quadratic equations. And we can factor them easily for each of them. So x squared plus x minus 6, you can easily factor that as x minus 2 times x plus 3, right? And x squared minus 7x plus 6, you can factor it as x minus 1 and x minus 6. Remember, we just find two numbers. If you add them, you get negative 7. And if you multiply them, you get positive 6. Okay, the same as the first equation. So just solve each equation by setting the factors of them equal to 0. So if you set x minus 2 equal to 0, you get x equal to 2. If you set x plus 3 equal to 0, you get x equal to negative 3. If you set x minus 1 equal to 0, you get x equal to 1. If you set x minus 6 equal to 0, x equal to 6. So we get 4 solutions to this equation, but again, we need to double check it. So that's always the case when we solve this kind of equations, either whether it's some radical equation or rational equation or absolute equation. You always need to double check the answer at the end to the original equation. So just let's just check one by one. So x equal to 1, so plug in 2, x equal to 2, plug in 2 for x in the original equation, we get a 2 squared minus 3 times 2. Take the absolute value of the whole thing. 2 squared is 4, 3 times 2 is 6, so we get the absolute value of 4 minus 6 on the left. On the right, it's negative 4 times 2 plus 6. So negative 4 times 2 is negative 8, so we get negative 8 plus 6, obviously. On the right, negative 8 plus 6 is just negative 2. But on the left, if you take the absolute value of 4 minus 6, you get the absolute value of negative 2, which is positive 2. So they're not the same. So you got 2 equals negative 2, in other words. So that means the solution of x equal to 2 is not the answer for the original problem. Okay, and then check the next one, x equal to negative 3. So plug in negative 3 for x in our original equation. We got negative 3 squared minus 3 times negative 3. Absolute value of that equal to negative 4 times negative 3 plus 6. Negative 3 squared is just 9. And 3 times negative 3 is negative 9, but you get another negative in front. So you get a plus 9. So you get 9 plus 9, and take the absolute value. On the left, the negative 4 times negative 3 is just positive 12. Take 12 plus 6 on the right. And the 9 plus 9 is 18. You take the absolute value is also 18. And on the right side, the 12 plus 6 is also 18. So, this is true. So x equal to negative 3 is indeed a solution to the original equation. And then you check the other two. X equal to 1, plug in 1 for x. In the original equation, we get a 1 squared minus 3 times 1. Absolute value of that on the left equals negative 4 times 1 plus 6. 1 squared is 1, 3 times 1 is 1. So we get the absolute value of 1 minus 3 on the left. Negative 4 times 1 is negative 4, so negative 4 plus 6 on the right. Negative 4 plus 6 is just 2. 1 minus 3 is negative 2. When you take the absolute value of negative 2, you get 2 also. So the left hand side and the right side are both 2. So that's true. So x1 is indeed a solution to the original equation. So the last one, x equal to 6, we just check that in original equation. So we get absolute value of 6 squared minus 3 times 6 equal to negative 4 times 6 plus 6. 6 squared is 36. 3 times 6 is 18, so we got 6 minus 18 absolute of that on the left. On the right, we get negative 4 times 6, which is negative 24. Negative 24 plus 6 is negative 18. So on the right hand side, we got negative 18, but on the left side, we got 36 minus 18, which is 18. Absolute value of 18 is 18. So we're going to positive on the left. The right and leg on the right again. So that's right. So 6 is not an answer. So we only get 2 answers for this absolute equation. There are x equal 2 and x equal to 1. So that's the solution to this uh, absolute equation. So it becomes a little more complicated, right? So that's the end of this section. We got 1 more minute. I can take one question now. Any questions for this section? Again, please make things if you missed anything as soon as possible by calling my cell phone number. It's 256-468-1507. Okay. Any questions? Anything want to ask me? So it's 1:50 now. I'm gonna take the road and you can go. So let me just stop the recording first.